Hey everyone! So, imagine you're trying to teach a robot to do everyday tasks. Pick up a spoon, stack some blocks, maybe even tidy up your kitchen. Sounds simple, right? Well, if you've ever worked in robotics AI, you know it's anything but. Different research labs use different frameworks, different architectures, and trying to compare what actually works best? It's like trying to compare apples to oranges when everyone's using different measuring systems. But here's where things get interesting. A new open-source project called Dexbotic just dropped, and it's basically trying to solve this entire mess. Think of it as the one platform to rule them all for robot AI development. Today, we're diving into what makes Dexbotic special, why researchers are getting excited about it, and what this could mean for the future of robotics. Let's get into it. All right, so what exactly is Dexbotic? At its core, Dexbotic is an open-source vision language action model toolbox built on PyTorch. Now, if that sounds like a mouthful, let me break it down in plain English. You know how modern AI can look at images, understand text, and now even control robots? Those are called vision language action models, or VLAs for short. They're basically the brain that lets robots see their environment, understand what you're asking them to do, and then actually do it. The problem? Research in this area has been super fragmented, different institutions using different frameworks and architectures, making it incredibly cumbersome to compare different approaches or reproduce results. If you wanted to test multiple robot AI systems, you'd need to set up completely different environments for each one. Nightmare fuel for researchers. Dexbotic changes the game by providing a single, unified platform. It supports multiple mainstream VLA policies simultaneously, letting users reproduce various methods with just a single environment setup. Think of it like this. Instead of needing 5 different toolboxes to build different types of furniture, Dexbotic gives you one really good toolbox that works for everything. And here's the kicker. It comes with much stronger pre-trained models that achieve significant performance improvements over existing state-of-the-art policies. Now, let's talk about why this matters so much. Many existing VLA models were built on outdated vision language models, preventing users from benefiting from the latest advances in AI. It's like building a brand new sports car but using an engine from 2018. Sure, it'll work, but you're leaving a lot of performance on the table. The robotics community has made incredible progress recently, with models like OpenVLA, CogAct, and others. But here's the thing. Each one required its own special setup, its own data format, its own training pipeline. For researchers trying to push the field forward, this was like being forced to learn a new language every time you wanted to try a new approach. Dexbotic tackles this head-on by standardizing everything. All VLA policies are uniformly divided into 2 parts: the vision language model part and the action expert part. The first part handles seeing and understanding, while the second part translates that understanding into actual robot movements. By breaking things down this way, you can mix and match components, test different approaches, and actually make fair comparisons between methods. So what makes Dexbotic actually better than what came before? Let's break down the key innovations. First up, better foundation models. Dexbotic introduces Dexbotic VLMs, which integrates open-source vision encoders with the latest large language models like Qwen 2.5, rather than relying on older models like Llama 2. This is a huge deal. Newer language models are significantly more capable at understanding and reasoning. Second, comprehensive pre-trained models. Dexbotic doesn't just give you the tools, it gives you a massive head start. They provide both discrete and continuous pre-trained models, including versions for single-arm robots and hybrid 2-arm systems. These models were trained on diverse data sets, including simulations and real-world robot demonstrations. Third, an experiment-centric framework. The system uses a layered configuration, plus factory registration, plus entry dispatch approach. This lets users quickly develop new experiments by simply modifying experimental scripts. No more wrestling with complex configuration files or rebuilding entire systems to test one new idea. And here's something really practical. Dexbotic supports diverse robot platforms like UR5, Franca, and Aloha, with a unified data format for training and open-source deployment scripts. Whether you're working with an industrial robot arm or a research prototype, Dexbotic has you covered. Now, does all this actually work? Let's talk numbers. On the challenging simpler end benchmark, Dexbotic enhanced CogAct outperformed the original by 18.2% absolute improvement. That's not a minor bump. That's a massive leap in capability. Even more impressive? Dexbotic enhanced OpenVLA OFT showed a 46.2% absolute improvement over the original. We're talking about nearly doubling performance on certain tasks. The improvements span across multiple benchmarks too. Simpler Env, Calvin for long horizon tasks, Manaskill 2 for pick-and-place operations, and RoboTwin 2.0 for dual-arm manipulation. This isn't just good in one specific scenario. It's consistently better across the board. And it's not just simulation. Dexbotic has demonstrated real-world performance on actual robot hardware. Tasks like set the plates achieved 100% success rate, and search the green box hit 80% success. These are real robots doing real tasks, not just simulations. So what does this all mean for the future of robotics? First, democratization of robot AI. By providing an open-source, unified platform with strong pre-trained models, Dexbotic dramatically lowers the barrier to entry. Smaller research labs, universities, and even hobbyists can now build sophisticated robot behaviors without needing massive compute resources or starting from scratch. Second, faster iteration and innovation. When researchers can easily compare different approaches and build on each other's work using a common framework, progress accelerates. We've seen this pattern in computer vision with frameworks like detection. Once the community rallies around common tools, breakthroughs happen faster. Third, bridging the simulation to reality gap. Dexbotic includes DOS Twins, a Real2 Sim 2 real simulator that ensures consistency between simulation and real world across visual, motion, and interaction dimensions. This means you can train and test in simulation with much greater confidence that it'll work on real hardware. The team behind Dexbotic has also committed to continuously updating the toolbox with the latest pre-trained models and cutting-edge VLA policies. This isn't just a one-time release. It's an evolving ecosystem. Look, we're still in the early days of truly capable robotic manipulation. But projects like Dexbotic, they're exactly what the field needs right now. Open tools, strong baselines, and a community-driven approach to pushing the boundaries. Whether you're a robotics researcher, an AI enthusiast, or just someone fascinated by the future of automation, Dexbotic is definitely worth keeping an eye on. If you found this breakdown helpful, hit that like button and subscribe for more deep dives into cutting-edge AI research. Got questions about Dexbotic or robot AI in general? Drop them in the comments below. Thanks for watching, and I'll catch you in the next one.